Okay, this is a quick example of linear functions and then interpreting slope. So we'll take a look at how we can write a linear function and then what its slope actually means in context. So a women's clothing store manager will spend a total of $3,000 on button-up shirts at $15 each and hats at $10 each. Write the number of shirts she can buy as a function of the number of hats. Find and interpret the slope. So what we want to do is we want to make sure that we understand what this means. Shirts as a function of hats. Now what I'm going to do is I'm going to go ahead and say S is going to be shirts, and that's going to be the number of shirts. Let me be clear about that. And then H, the number of hats. Alright, so now there are my variables. Now, when I see something as a function of something else, that immediately tells me which is the y coordinate. Now, when I say y, I mean like in an xy coordinate, xy ordered pair. Okay, so we normally have this and this, right? And this right here would be y as a function of x. Okay, so if that's the case, then in this situation, we have shirts as a function of hats, then that means that shirts is my y. Shirts as a function of hats. Okay? So this is what we're going to use, and that's going to help us to later interpret the slope. Alright, so now let's write an equation of this situation. This manager is going to buy, presumably wholesale, these button-up shirts for $15 each. So each shirt is $15, and each hat is $10. Now I didn't necessarily put those in a particular order. I don't know, alphabetical maybe. It doesn't really matter. So that's equal to $3,000. Now, there is my linear equation. I know it's linear when I set it up because it's standard form, right? So that's the form of a line. Sometimes these say write a linear equation. So, all right, so if I know that this right here is my y variable, I need to find the slope and interpret it. Two things they want me to do, okay, after I write the equation. So I'm going to find my slope by getting it into slope-intercept form. So I'm going to get S alone. It's like saying I'm going to get Y alone. So here I go. Minus 10H, minus 10H. So I have 15S is equal to, now I'm going to put the H at the front, right, because it's like that's my X, and I want to continue to write this in slope-intercept form, like y equals mx plus b, basically. Alright, so now I'm going to divide, well, I'm trying to get the green. I'm going to divide by 15 and divide by 15. Okay, so my S is this fraction right here. I'm just going to reduce it. Negative 2/3. There's my H. And then if I take 3,000 and divide by 15, I get 200. All right. So let's finish this up. There is my equation in slope-intercept form. This was my equation in standard form, and that was just the easiest way to set this one up, to just set it up in standard. So now we found the slope. So my slope is negative 2/3, right? That's the slope right there. What in the world does that mean? We're going to interpret it now. So let's look back at what was what. In other words, right here. If I look at my little help right here, then I see that H is X and S is Y. So slope is rise overrun. In other words, it's y, change in y over change in x. So this evidently is, let's keep on going, is the change in S over the change in H. Let me say it again. It's the change in the shirts over the change in the hats. So now we're ready to interpret it. Here we go. So notice that the 2 is negative. So I'm going to say for every decrease because it's negative, decrease of 2 shirts, she can increase hats by 3. For every decrease of 2 shirts, she can increase hats by 3. That's what this means. There's the negative, that's the decrease. This is 2, there's the 2. And in the fact that the 3 is positive, that's the increase. And then lastly, there's the 3 and there's the 3. All right, I hope this was helpful. Thanks for watching.